In 13.1, we are going to talk about factoring using our greatest common factor. Our first definition is to factor an expression means to write it as a product. So in our examples, we're going to look at writing what we have as a product of two pieces. And there are certain steps that we need to follow when using our greatest common factor. The first one says make the prime factor tree for each term in the polynomial. So this right here is our polynomial, and we need to make a factor tree for each term. This is one term, and this is the other term. So if we have a factor tree for 10y squared, that breaks up into 2 times 5 times y times y. Then for 15y, we can break that into 3 times 5 times y. Now our greatest common factor, our second piece here, find the GCF, greatest common factor, by circling common pairs of factors. So we see that we have a 5 in both of these trees and a y in both of these factor trees. So our next step for our answer, write the greatest common factor outside a set of parentheses. So let's do that. We have 5y, those are our common pieces, and then inside we'll have a pair of parentheses. Step 4, put the remaining uncircled factors inside the parentheses. So up here in our first factor we have a 2y, so I will write that first, and then I have a plus in between my two factors up here, so I will have a plus, and my piece left in this one is just a 3. So I have 2y plus 3. And then my final step is to use the distributive property to check your work. So if we do that, we would have 5y times 2y. 5y times 2y gives me 10y squared, and then 5y times 3. 5 times 3 is 15y. And that's what I started with. So I know that this right here is my answer. Okay, let's look at number 2. Number 2, we're going to start with our first step, make the prime factor tree for each term in our polynomial. So we have 20x squared. We can turn 20 into 5 times 4 times x, but we can still break up this 4 here. So I'm going to continue to write that again. We have 5 times, instead of 4, I can write 2 times 2. And then I still have x times x. So now this is the prime version of my factor tree. I can't break up those numbers any further than that. So then I'm going to find the prime version of my other term, 24xy squared. I can break 24 into 4 times 6 times x times y, but again I can still break that up, so I'm going to break it up again down here. 4 times 4 is 2 times 2, or 4 is 2 times 2, and 6 is 2 times 3, then times x and times y times y. Okay, then my next step is to find the greatest common factor by circling common pairs. So I have a 2 and a 2, and then another 2, and I have an x and an x, and those are all my common factors. Okay, so now for the answer, I write my greatest common factor outside. So my greatest common factor would be 2 times 2, which is 4x. So I'll write that here. 2 times 2x is equal to 4x. And then I'm going to have my parentheses. And my first set of parentheses, I have 5x. And I've got a subtraction sign in the middle now. And then I have 2 times 3 times y times y. 2 times 3 is 6. And I need a little more space in my parentheses. 6. And y times y is y squared. So this is my greatest common factor for number 2. Okay, let's look at number 3. This time we have 3 different terms. So we're going to have to find our factor tree for 3 terms. This one, 28, we have 4 times 7 times a times a. And we can break that 4 up even further into 2 times 2. Okay, my next term, 21b squared, I'm going to break that one up into 3 times 7 times b times b. And my last term, 35c squared, I can break that up into 7 times 5 times c times c. Okay, now I can find my common terms. So in each one, I have a 7. And then all my variables are different this time. So that is my only common factor in all 3 of these factor trees. So I'm going to take that 7 outside my parentheses. And then inside I'm going to write what's left. So up here I have 2 times 2 times a times a. So 2 times 2 is 4 and a times a is a squared. Then I have a plus. 3 times b is 3b squared. Now I have a minus sign and then 5 times c. So 5c squared. And that is my final answer for number 3. Okay, one more example here. Let's look at this one. Again, we have 3 factors. So we can break that 8 up into a 4 times 2 times y, and that breaks up into 2 times 2 times 2 times y. So we have 16xy squared. 16 is 8 times 2 times x times y squared, which is y times y. And then we break that up further. 8 is 4 times 2 times 2 x times y, and then again even further, 2 times 2 times 2 times 2 times x times y. So that is my factor tree for this term. And our last term here, 40y squared z squared. 40 we can break up into 4 times 10 times y times z. Let's break that up further. We have 2 times 2 for our 4, and then 2 times 5 for 10 times y, and z. Next, we're going to find our common terms. We have at least 1, 2 in each one, so I'm going to underline our answers here so we can see them better. We have a 2 in each one, we have another 2, and another 2. So each one has 3 2's. Then let's look at the variables. I see a y in each term and a second y in each term. And then that's it. So let's look at writing our final answer. So outside of parentheses, we have 2 times 2 times 2, which gives me 8. And then we have y squared. So 8, y times y is y squared. And then my parentheses. So everything else is going to go inside. If I look at my first one, I used up everything in that factor tree. So that means all I have left is a 1. 8y squared times 1 gives me 8y squared. That's my first term. Then I'm going to subtract. Down here I have a 2 times x. And then in my final term I have a 5z times z, which gives me 5z squared. And that is my final answer for number 4.